All right, transformations. Definitely a fun topic. So we have these graphs you see on your page, and we have a bunch of different functions. And the question is for you to describe how it's being transformed from its parent function or from its common function. So for example, we have f of x here, and its common function would be just the square root of x. So take away that add 2. Um, so this is the graph of f of x right here. So in other words, how has it changed? Describe how it is transformed from the square root of x. So go ahead, put me on pause, and write it down. Hey, you didn't pause me. Okay, same thing here. This time we have f of x equals square root of x minus 2. So just one thing, and maybe I should have given you this hint the first time, is if I think of what the common graph square root of x looks like, it's at 0, 0, 1, 1, 4, 2. Okay, I could keep going. So this is what the parent or the common function looks like. So we're asking, how is this different than this? Maybe this one's a little more obvious. Okay, so this one's a little bit harder. Same thing, if I have my common function, how is this graph different? It might not be quite as obvious this time, but it is something that you've learned before, so really think about it and see if you can remember. So yeah, write it down. Very similar, this time we have f of x equals 2 times the square root of x. So same thing, how has this changed? Go ahead and write that down. All right, now you notice something else going on in this graph. We have f of x equals the square root of negative 2x. So describe in words what's happening here. How is it changing? And again, that's in comparison to its original graph or the parent graph. So what has changed? Last one here, very similar. We have negative 2 square root of x. So in comparison to its parent graph or its common function, what do we have? Can you describe in words the difference? Okay, so I hope that you were able to write some things down and pause me every single time. So now we're going to apply that to what we see here, this example. We want to draw h of x, this is h of x right here. We want to draw, and we have f of x on the graph, so we want to draw h of x with these given transformations. We're going to transform f of x so it has these transformations applied to it. So one hint that I want to give to you guys is that it really only matters, the corners. If I can transform these 4 corners, then we should find some success. Another thing that I want you to think about is what we just did on the last page. We started by just looking at the equation itself and writing into words how it would be transformed. So, for example, and I'll kind of help you guys out with this one, I have f of negative 2x minus 3. Well, first of all, what's that negative going to do? I'm going to write it in bullet point form. Well, the negative, if you guys looked at the page before and kind of found some patterns, that's going to make it reflect over, is it the x or y axis? Look at your previous examples. It would reflect over the y-axis. Okay. How about that negative 2? Now, this might be the one that we might have struggled with on the pages before. Now that -2 is being multiplied inside of the function. Instead of being like 2 times f of x, it's f of -2x. So, because that's happening, we're going to have a horizontal shrink by 1/2. The last transformation that we notice here is that -3. So again, looking at the previous page, what do you notice is happening when we add or subtract a number outside, I'm using air quotes here, outside of the function? Well, it would move down 3. Okay, so I've literally done the hardest part for you guys. So what I'd like you to do right now is apply these 3 transformations to each of these 4 corners. So I'd like you to put me on pause. When you're done, go ahead and unpause me and we'll see how you did. Good. So you can see that I really tried to coordinate with the colors of the corners here. So let's start with this one over here. So remember, above we wrote down these 3 transformations. So I started by reflecting this point over the y-axis. So that brought that all the way over to -6. Now we have a horizontal shrink by 1/2. So horizontally, or think of your x values, I'm going to multiply by 1/2. So now that's at -3, down 3. I did that process for all 4 points. Okay, so hopefully yours looks something like mine. All right, so just in conclusion here, transformations of functions include resizing, whether that's stretching or shrinking, translating, which would be shifting, and reflecting, which could be flipping functions.